name is Todd Matters. I'm the CTO at RackWare. Today, we're going to be discussing migrating workloads into the Microsoft Azure Cloud. The RackWare software supports multiple use cases, including migration and disaster recovery and hybrid cloud management, but today we'll be focusing just on the workload migration piece. Now, the RackWare software is designed to be able to migrate workloads from on-prem into the Microsoft Azure Cloud. This includes physical servers, so if you have physical servers, running databases, or maybe clusters or large ERP, the RackWare software can be used to migrate those physical server workloads into the Microsoft Azure Cloud. Software, of course, supports replicating virtual machines. This includes virtual machines running on VMware or Hyper-V, or for that matter, other hypervisors such as Xen or KVM. All those virtual machines can be migrated into the Microsoft Azure Cloud using the RackWare software. Likewise, if you're running the Azure Stack on-prem, the software can migrate those workloads into Azure as well. Increasingly, a use case that's going to be important is cloud to cloud. The RackWare software, again, has an architecture that allows it to replicate workloads from other clouds into Azure. So let's say you have workloads running in Amazon or Google, and you want to migrate those into Microsoft Azure. RackWare software can be used to perform those migrations just like it would migrating from on-prem into the cloud as well. Now, there are several key points about the software solution. The first is when the software is replicating and syncing, this is completely non-destructive to the origin environment. You're still running transactions during the replication. After the replication, your application owners can come in and do thorough testing in the target environment, all the while you have not disrupted your production operations. When you go to do the final cutover, then the RMM can do a delta sync from the origin to the target, so your downtime is an absolute minimum. The delta sync is highly efficient. It only transfers over the changed bytes from origin to target. There's a huge degree of automation here. There's a whole console that supports multiple users, role-based access, things like this. There are also specific features for some of the more difficult workloads. So I mentioned clusters. The software supports clusters or specific features around that, but also large servers running all kinds of applications can be supported with the RackWare software. Again, just to note, the software does support disaster recovery. There's a policy engine that sits on top of it, and the whole point with the DR solution is, like migration, you can resume your production operations in the target Azure environment. Now, so much for slides. Let's move on to the demo. I'm going to turn this over to David Gioso. He's one of our senior SEs. He'll be doing a demonstration of a migration.
Thank you, Todd. Today, I'm going to show you how to perform a live migration of a typical hybrid infrastructure into the Azure Cloud. There are 5 simple steps to perform this migration. First, deploy your RackWare RMM from Azure Migrate. Then upload your list of hosts to migrate. We call these waves. Input the Azure Cloud credentials. Assign the target network information. And then press play to perform the live migration of all the workloads. So here's a view of the topology I'll be using for this demonstration. For the origin hosts, I have one on-premise virtual machine, and I have a host running in Amazon Web Services. There is layer 3 network connectivity from my source host to the RackWare RMM that is deployed in the Azure resource group. And the only port I need to have open is TCP port 22 to perform all these operations. You can find the RackWare Migration Manager in the Azure Migration Hub. Simply follow the steps to deploy the RackWare RMM into your Azure account. You'll find this under Azure Migrate, Servers, Add a Tool, RackWare Cloud Migration. So let's get started. First screen we're greeted with is the selection to create or upload the WAV file. Simply drag and drop the WAV file onto the upload section. This will create the new WAV and all the hosts we wish to migrate. The WAV will display the lists of all the source hosts, the target goal, and the current status. Now that the WAV has been uploaded, the next step would be to add the Azure Cloud credentials. I have my account credentials already added and available. They contain my tenant ID, client ID, and which data center to be deployed into. Next, I will configure the WAV to automatically deploy the hosts into my Azure resource group by clicking on the Auto Provision link. First, I select the cloud user that was created earlier. Then provide the target network and resource group information, such as data center region to deploy into, the resource group name, and the network information. We also have the ability to set up network profiles to help expedite this process. Once the auto provision settings are configured for the WAV, I can select the number of parallel operations I wish to perform against this WAV. A setting of 0 will start all the operations simultaneously. So now everything is ready, and I just have to press the play button to start the live migration process. First thing that happens is the RMM connects to the source hosts and performs an examine operation of each of the workloads. And this is where the RMM gathers all the metadata about each workload, such as the OS type, number of CPUs, disks, port connections, and more. It uses this information to provision similar resources in the target environment. By default, it uses similar resources, but you have the ability to override and choose a specific instance size. So here we can see the RMM provisioning those target resources into our Azure resource group. Then the RMM performs the additional operations, such as transferring all the data and the attributes to the target drives. Our first host is completed, and there's our second. So now that the initial migration is complete, the source hosts are now online and running in the target data center. So you can bring in your application owners to validate the new targets without any disruption to your source environment. The RMM uses a file-based synchronization technology that gives us the ability to perform a delta sync operation. So for follow-up syncs, the RMM will only sync the data that has changed since the last synchronization operation. To start the follow-up delta synchronizations, just press the play button again, and the delta sync will start. All sync operations will have a status and display elapsed time each operation took. And this allows us to easily plan for the final cutover of those source workloads. You can perform as many delta syncs as you want until you're ready for that final cutover. Thank you very much for watching this presentation. You can reach us at info@rackwareinc.com.